The Gaia Space Telescope. What is Gaia? The Global Astrometric Interferometer for Astrophysics spacecraft is a space-based optical observatory designed and built by the European Space Agency to survey the galaxy and allow for the largest and most accurate three-dimensional map of the galaxy to be created to date. Where is it? It currently resides at the Lagrange 2 point behind Earth orbit. A Lagrange point is a position where the gravitational pull of two bodies is equal to the centrifugal force of an orbit. What this means is that the Gaia spacecraft is at a point where, relative to the Earth's position in the solar system, it does not move at all. When did it get there? Gaia was launched on December 19th, 2013, and its planned retirement is sometime in 2022. So there's a possibility for mission extensions up to 2025. Who launched it? The EU did. In a sense, this project is only run by the ESA, which means that that involvement in the program is mandatory for every EU member state. There's also some level of cooperation with the Russian Federation, as it was a Soyuz rocket that launched Gaia into its orbit, even though that particular Soyuz was a Europeanized version. The Gaia spacecraft was launched as part of an initiative by the ESA to create a detailed map of the galaxy. To date, it has recorded, at least preliminarily, about approximately 2 billion different stars in the galaxy, with an error rate as high as 20% for those that are approximately 30,000 light years away. Though stars significantly closer can have that rate dropped to as low as 0.001%. The reason that this is so important is because it allows us to predict how the galaxy evolved into its current state and how it will continue to evolve well into the future, both with much greater accuracy than before. How does it do this? Gaia is capable of achieving its feats via the use of two optical telescopes, which actually collect the light, and the use of its astrometric and photometric instruments, as well as its radial velocity spectrometer, to analyze the data that the telescopes receive in order to allow the device to plot its data. What this means is that Gaia can create, for current technology, the highest quality measurements of distant stars possible. This is done via the parallax method, which means that it is done by comparing two nearly identical pictures and seeing the difference between them. This allows for the calculation of relative position, of velocity, and to some extent, through comparisons, gravitational interactions between neighboring stars. A particular question that might be asked is, how effective is Gaia compared to any other previous astrometric missions? The answer would be, surprisingly, is to compare it to its predecessor, Hipparcos, which was able to accurately measure 100,000 stars, to a million stars to high precision, 100,000 stars to high precision, more than a million to lesser one. Gaia has 10,000 times the target and 100 times the accuracy. What is astrometry? Some might wonder, what is astrometry? It is a specialization of general astronomy that focuses on precise measurements of position and movements of celestial bodies. Now, how is this relevant to optical applications? Simple. One requires some form of telescope in order to be able to actually take any of those measurements. To get an accurate enough measurement to make astrometry a viable field of study, especially when talking on a galactic level, requires the use of some of the highest power telescopes imaginable, in this case with a 106 CCD focal plate. Why are mirrored plates used instead of simple lenses? The answer is twofold. One, because it allows for significantly greater levels of magnification, and two, because this eliminates lens diffraction blurring. In layman's terms, this is the equivalent of using a 1 billion pixel camera. making Gaia the largest and most powerful telescope ever built by humanity currently. Photometry is similar to astrometry in a sense, that both are studies that focus on quantitative measurements. Photometry is dedicated to the measurement of light as its brightness is perceived by the human eye. While this is, on the face of it, might not be that interesting or tell us anything of any actual value, in actuality, there's a great deal that can be learned, including the heat of the star, as well as its age to a certain extent. On the level that Gaia works at, even this information is crucial to understanding in our galaxy. A radial velocity spectrometer is a very useful device. On Gaia, particularly, it is designed to measure the line of sight velocity of distant stars. Combining this data with Gaia's astrometry devices allows for the creation of a three-dimensional map of incredible quality. This works only in the infrared light range, which is then dispersed and picked up by the optical module that processes and magnifies that data. Results. Gaia has observed more than 1 billion stars over 70 times over the course of a 5-year period. It is not just all of those stars that can be easily tracked. That is a boon, as an estimated many thousands of exoplanets are expected to be discovered by Gaia in the near future. And indeed, the project at the very inception of its planning was meant to be built upon an interferometry system, hence its name. But an optical system was later selected due to its ability to collect more signals, as well as being able to detect fainter ones as well. The total cost for the mission is approximately 740 million euros. That includes construction, launch, and continued maintenance of the Gaia spacecraft and the facilities that analyze the gargantuan amounts of information it produces. There have been several proposed replacements for Gaia once its mission has finished. One such proposal, and in my opinion the most likely one, has been tentatively called the Gaia Near proposal. It calls for the creation of a new space telescope, much like Gaia itself, only that it works in the near-infrared light band. There are several benefits to this proposal, including reduced costs in both design and support infrastructure, as well as the longer wavelengths of light that are used for more stars to be plotted, even though they are not available for elemental analysis. 2 slides have been created with all sites that have been accessed for information, split on whether they were accessed for pictures or actual knowledge. They have been separated for ease of understanding the origin of everything used in this presentation. And a copy of the slideshow has also been submitted so anyone